What do brittle fracture surfaces look like? Imagine a glass breaking or a ceramic plate shattering into sharp, clean pieces. That's a good way to picture what a brittle fracture surface looks like. When materials fail suddenly and without warning, they leave behind surfaces that tell a clear story. These surfaces are usually flat and shiny, almost mirror-like, with very little sign of stretching or bending. Unlike ductile fractures, which show rough, deformed edges, brittle fractures are smooth and clean. If you look closely at a brittle fracture surface, you will see a pattern of flat, shiny facets. These facets are the result of the crack moving along specific planes within the material, called cleavage planes. These planes are like the natural cracks that form along the crystal structures of the material. The surface often looks like a series of flat, shiny patches that fit together like a jigsaw puzzle. Sometimes, you can see chevron or river pattern marks on the surface. These patterns point back toward where the crack started, kind of like the ripples in a pond. They help forensic engineers figure out how the failure happened. The surface is usually very smooth because the crack propagates quickly through the material. This rapid movement means there is little plastic deformation. No stretching or bending occurs before the material breaks. The crack spreads at high speed, sometimes almost as fast as the speed of sound in that material. This quick failure often causes a loud noise when it happens. From a microscopic point of view, brittle fracture occurs when atomic bonds break along the cleavage planes. This separation creates the smooth, faceted look seen on the surface. The fracture does not involve much plastic deformation, so the material does not bend or stretch much before breaking. Materials prone to brittle fracture include ceramics, glass, some polymers, and certain metals under low temperatures or high strain rates. Recognizing these features helps engineers understand why a part failed suddenly. By examining the shiny, flat, and faceted surface, they can tell if the failure was brittle. This knowledge is vital for improving material choices and design to prevent unexpected, catastrophic failures. In short, brittle fracture surfaces look like shiny, flat patches with clear, faceted textures. They often show patterns pointing back to the crack origin, and they reveal a failure that happened quickly and without warning. This visual evidence helps us understand how and why materials break in a brittle manner.